Greetings, we are Group 12 from Lab P2 and we would like to show you our virtual analytics tool, which will aid in correlating security information to draw conclusions on attack detections and analysis confidently. But before we jump right in, I would like to start off with detailing the data logs which are utilized for the dashboard. There are logs which we created ourselves and also logs which we sourced from online as shown on screen here. The data cleaning process first starts with collection as shown in this table. This is how the logs were generated or sourced from online. The next process would be filtering, which would be mostly applied to our self-generated logs via the use of grep, AWK, bash scripting, and the filtering of PCAP files using Wireshark. For the normalization phase, we decided to pass all the various log messages into a standardized comma separated value or CSV format to prepare for correlation. As most of the log sources were generated with logrotate and syslog, the format of the logs are very similar, hence making the normalization process almost standardized. However, some logs were of different formats, so we had to use scripts and Wireshark to normalize the data as shown here. Finally, we move on to visualization and correlation via our dashboards, where we have split them into two dashboards. One covering network-based attacks whose source logs are the network logs, and also ransomware attacks which utilizes the Windows logs. We'll start with the Linux logs. Beginning with vulnerability scanning, we displayed the IPs matching to their destination port and count via a parallel coordinates diagram, which clearly establishes who is connecting to which ports how many times. Furthermore, by correlating this information with an intrusion detection system's logs, in this case Snort, with the rules being set on Snort to detect port scans, one can reduce false positives as benign high-volume server requests can be sieved out via Snort. Next up, we have the file and directory discovery, where on the left we can see a line graph of the number of response status codes. This is charted against time. On the right, we have a network diagram which displays the response codes that are being sent to their respective IPs. By utilizing both panels, taking particular notice of a large number of 404 response codes, one would be able to deduce whether a file and directory enumeration is taking place, and it is shown that a large number of 404 responses are all originating from a single IP, serving as defining pieces of evidence that enumeration is taking place. Down the line, we have the detection of brute force attempts, specifically password guessing attempts. Starting off with the priority relation to facility punch card, this helps to visualize the number of entries being generated based on each priority and facility. This chart details what are the facilities and priorities of the messages within the logs and can be used to identify areas which have a large amount of entries being generated. Moving on, we have the unit breakdown heat map, which showcases the amount of entries being generated by the services into log sources in a time frame. We will use this to cross-reference against the punch card to see if relevant service logs have increased. Thereafter, we have the bar chart for failed messages, which displays the amount of failure messages there are for various services and utilities. An increase in the amount of error messages would be a telltale sign of a brute force attempt. By cross-referencing these three panels together, one will be able to narrow down as to where a brute force attempt might be taking place based on the logs, and to verify if there truly is a brute force attempt. Now onto privilege escalation via valid, default, and local accounts. The IP relations to user accounts network map provides a top-level view as to where each account is being accessed from and whether there are concurrent logins. The memory usage line graph plots the processes against time, which can help identify anomalous usage at unexpected times. By correlating these two panels together, we are able to piece together the evidence to come to a conclusion as to whether there has been a successful escalation of privileges by an intruder who utilized valid accounts, especially during abnormal hours. Finally, for the network denial of service via direct network flux and/or reflection amplification, we have the bar chart to showcase the traffic flow of IP addresses that are flowing into the network. This panel immediately indicates as to whether the network is under a denial of service attack. Furthermore, by correlating the memory usage chart at the same time frame as the traffic flow chart, a high spike in memory usage can potentially indicate the event of a DOS attack. Alternatively, a sudden dip to zero memory usage could signify a successful DOS attack, which has caused the system to crash. Finally, we have reached the Windows dashboard meant for ransomware detection. Starting off with the IP address connections by protocol sun key diagram, the detection of SMB and SMB2 protocols in significant quantities are an indication of ransomware activities abound. However, this alone could be a false positive. In the SMB and SMB2 methods execution panel, we can then dive into all SMB and SMB2 commands sent to the victim device over a period of 5 minutes. Typically, ransomware begins by sending multiple read commands to read the data of files, followed by create commands, which creates encrypted replicas of the original files, and write commands, which writes the encryption algorithm along with the original data. Thereafter, there will be a delete command, which will delete all original files after the completion of the encryption process. In this example, the original data source was trimmed down to 10% of its original size due to the massive amount of data. Hence, the delete command was missing from the panel. The next panel indicates known ransomware file extensions, which displays the count of matching file extensions that are found in the info column from the SMB and SMB2 traffic from PCAP files. The events are first sanitized via regex commands, and all file extensions from the remaining events are compared against a lookup list of known ransomware file extensions, whereby events with non-matching extensions will be filtered out. For the storage usage against data write request from attacker panel, one will be able to see how a typical ransomware would behave, whereby the amount of data being uploaded, as shown in the white line, indicates the payload being uploaded, and the amount of free storage space dips, indicating that the encryption process might have started, followed by the free storage space returning to its original size, indicating that deletion has begun. Finally, in the last panel, it shows the average command length out of the XML win event log and the maximum command length out of each command entered. As shown, there is a spike in the size of the command length, typical of that of ransomware, which is larger than the typical length. In conclusion, by correlating these 5 panels together, one will be able to gather strong evidence to determine whether a ransomware attack has occurred. Thank you for listening.